up, guys? This is Pavel from Coding Jam Session. Welcome to another episode of live coding series. Today, let's give a shot to solving the second day of our Harvard of Code from 2023. So let's go together through the story again, and let's dive into the code right after. So let's see. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island with all the snow and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game, which is our puzzle input. Each game is listed with its ID number, like the 11 in game 11, followed by a semicolon separated lists of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. For example, the record of a few games might look like this. So each row is one game, and each game can have a few sets, which are the cubes that are taken out from the bag, then put back, then another set of cubes taken out from the bag, put back, and again. Okay, so wait, is this the, no. Yeah, so every game, a few times the guy is taking out some cubes, and we've got listed them in this row and separated by semicolon. Okay, I get it. In game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue, 4 red. The second set is 1 red, 2 green cubes and 6 blue. The third set is only 2 green cubes. Okay. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. Which games would be possible if those would have been in the bag? Okay. In the example above, games 1, 2, and 5 would have been possible. 1, 2, and 5. 1, 2, and 5. Oh, okay, because in the game 4 we've got 15 blue, so that's more. And here in one set we've got 20 red, which is more than 12. Okay. Who would have been possible because I'll show you. Oh yeah, there we go. If you add up the IDs of the games that would have been possible, you get 8. So we add up those IDs. Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? Okay, so let's start with the same thing as the last time. Let's create our files, index.js, add 2 input files, input.txt and paste input.txt. And let's start with obtaining and parsing data. So what we're gonna do is okay. Oh no. Okay. Our file name variable as first is gonna equal to test input at the beginning. Let's just dive into the previous code and copy some stuff because we're gonna measure our performance as well. So let's do this. Let's copy this. That's just the way we've measured the execution time last time we've done this. So we're gonna do the same in day two. Okay, fs fs and data equals to first the create file sync or file name. And we're gonna split it by lines, just like the last time. Okay, and how do you want to parse the data? That's thing. Okay, let's just console log the data first, see what we got. Did I copy the test input? No, I didn't copy the inputs yet. Sorry, started coding, we don't have the inputs yet. So test input, let's get your puzzle input and copy that one as well. Okay. All right, and let's get our function. Part one. We've got our self function. Right, let's have a look how our data. Oh, was there no such file as test input dot txt. Okay. So here's our parse data. So we've got the array of array of lines. So each line, each element in an array is a string with a gain. Now let's just think how do we want to parse the gain. So we definitely want to parse every single line. And how do you want to do that? So we can split we can definitely split by we've got a column that separates the game from the sets. The sets are separated by semicolons, and the rolled cube colors are separated by the commas. Okay. Let me quickly think. Let me quickly think. How do we want to map it? So let's actually make let's make one big array that's gonna contain an array for each game, and that array of each game is gonna contain an array with uh, with the cubes that were rolled. So what we wanna do, what we wanna get is what we wanna get is a structure like this, and have like eight, 9 red, whatever. So this is gonna be the list for each set. I just wanna show you what I mean. So what I mean is one big array that's gonna contain games. So this is an array of game, and each game is gonna contain array with sets. So every set is gonna be in a separate array. So that's how we want. I think that's how we want to parse the data. That's the best way, I think. So let's see how we do that. How do we do that? So we will want to, when we go through every single line, we will want to return because we do not need to save those index numbers, because we're gonna have indexes of each game is gonna have index in an array. So this number is useless to us, so we don't need to save. So we will simply split by a semicolon and space. So that's the deal. If we split like that, we get an array of 2 elements. So we want a second element after the split, which is on index 1. Then we get this full row. And then what we want to do is split it by a semicolon with space. Yeah, so we're gonna get all the sets, array of sets. And if we have array of sets, then we want to map it, because we want every single element of a set. So free blue, for red, and so on and so on. We want as a separate element if, in an array. So what we're gonna do is we're gonna map it. And every, how do we name it? I don't know, every rollout, I don't know, something like that, roll, whatever. Every row is going, we're gonna return, we're gonna split it by, this time, a semicolon and space. Okay, just like so. So if we're gonna console log the data now, we've got an array of games. This is a game, and each game is an array of sets, and each set is containing the elements. But I think it's not correct. It's not the way we want it to be, because free and blue is separated. Oh, because we didn't have comma here, yeah, so we've been speaking by space, not by comma. There we go. Now we've got free blue, for red, and each set is separated elements, so that's good. So now, if we've got our data parsed, we can simply go towards solving the puzzle. So what we got? We're looking for games that are possible in the bag that contains those chips. So when we're gonna go through games, we need to go through each set and see if any of the rollouts is bigger than those maximum numbers given in here. So let's declare our mm, let's declare our bag. So our bag is gonna be an array containing 12 red cubes. That's gonna be first element, 13 green cubes, and 14 blue cubes. Okay. And what is the sum of the IDs of those games? Okay. Okay. So what we're gonna do is just like the last time, we're gonna go with this function to sum up the accumulator the game, and initial value of our accumulator is gonna be 0. So we're simply gonna sum up the IDs of every single game that meets our expectations. So we need to look through the game. So for each set within the game, what we're gonna check is here's the funny thing. I know what we're gonna do. I'm gonna show you something that you might know or you might not know. I don't know in the JavaScript. Well, that's actually a very nice thing. So if we've got something like this, I'm gonna look to the console, a string like that. Not a string. Well, I wanted to show you. If I'm gonna parse int a string like this and log into the console, look what's gonna happen. We're logging in 1. So when we're parsing in a string that contains a number and a word or whatever, if it's a single number, then it's gonna simply console log. It's gonna use this number to parse it to the integer and ignore everything else that is not a number. It's just because of this what I showed you in the previous video, which is this. Which is giving us true. So this string is actually is considered a number by JavaScript. You know what I mean? But if we're gonna use this, then it's not. It's giving us false. That's why if you're using the parse integer parsing function on a string like this, it's simply gonna return us the integer version of our 1, which is very handy. So that's what we're gonna use, I think. That's gonna be quite helpful. So let's extract the colors in each set that we've had. So let's blue chips is going to be it needs to be an integer, so we're gonna use parse it, and we need to filter the element that contains the string blue. So what we're gonna do is out of our set we're gonna filter out element that includes the phrase blue. And in this case, look, if I'm gonna remove the parse int, actually, and console.log b, you're gonna see this 6 blue, yeah? You're gonna see that element. Or not. Or not. Element includes the why do we okay wait where is my console? Maybe I don't see that. Oh, because we're not invoking the function. What the hell? I just commented it out. I wonder why I don't see the console. So, oh, there we go. You see? Blue. And you can see that B is a element, is this element, but we're returning an uh, mm, right, and now if I'm gonna, yeah, so we've got the free blue element. It's actually included within an array, but it's fine because if I'm gonna use the parse integer function, then we're gonna get b equals to 3, or not a number. Of course, if there's no b in a set, then there's gonna be not a number. So that's how you extract it, because yeah, that's actually quite handy as well. So if we get an array with a one element which is a string, and we're gonna parse use the parse integer function on it, it's the same way. We're gonna simply get 3, which is quite handy as well. So it's flattening the array as well. This function is quite nice. It's quite handy to know these things, I think. Anyway, so we've got the blue. We need to repeat this for. Let's just copy and paste. So we need to repeat this for green and red. Green and red, and it's gonna be green and red. So we've got for each set we filtered out the number of colors that were taken out of the back. So what we need to do now, yeah, because we not only need to check that in a single set, if in a single set we're within those numbers, but we need to say that every single set is not exceeding those numbers. So let's declare a boolean variable and set it initially to true. So initially we say, okay, none of this is exceeding those numbers, yeah. But then we're gonna check for every single game. We're gonna what I'm talking about, for every single set, we're gonna check if this condition is met, and if it's not, we're simply gonna set this to false, and then we're gonna know that if uh, if if it's gonna end up being true at the end, that means that none of the sets had turned it to false, which means that none of the set exceeds those numbers. Okay, so let's type in the condition. So we need to know that our number of blue chips is greater than our bag, and which blue ones is the last one, which is index 2. So we're checking if b is greater than our number of blue chips, and we're gonna not and or, because it's enough that only one condition is met, not all of them. So we're gonna check if green is greater than our bug 1. Green is a second element, and or I mean we're gonna check if our red is greater than bug 0, which is our first, which is 12, yeah. And if those conditions are met, we're simply gonna set our response to false. And now we know that if those conditions are met, that means the game was impossible because it was exceeding those numbers. But if it's true, the game was possible because none of the sets was above any of those numbers. So now we simply check if response is true. Then we're gonna return a accumulator plus index, which is oh, we don't have access to index. Wait, can we access index in reduce function or not? I don't even know. JS reduce. Let's have a look in the if there's a third parameter or not. Initial value, accumulator, current index. Oh yeah. So that's gonna be the third value, I think, yeah? So we've got 0 and I. Not. No? What? Oh no, what the hell am I doing? Accumulator, game, and here, the second variable is our index. Okay, now we've got access to our index, that's fine. So accumulator plus index plus 1, because we can see that we're starting the game 1, 2, 3, 4, but indexes in an array start from 0, so we've got I plus 1, and that's fine. And if that's if that's not true, then we'll simply return accumulator, because that means that the criteria wasn't met. Okay. Then let's call the response, and then let's console.log our response. So we should be. So what is our test data response? We should get 8. Let's have a look. And there we go. Our response is 8. That's fine. So let's just type set our file to the regular input data. Let's see it on the full data, and let's have a look if we're gonna get a star. We've done it in 5 milliseconds again, which is very quickly. No issues in there, no problem. And let's type in 1931 and submit. And boom, we get a gold star. Lovely. So solution was fine. So just I'm just gonna quickly go through, because I know that I'm quite chaotic when I'm talking, but so that you understand. So what we did is we parsed the data. Let's just go back to this console log. We parsed the data. So and let's just put test input so we don't get the full data. We parse data in an array of games. So the big array is containing each element of the big array is a game, and this game is an array itself, and it contains arrays of sets. Each set contains elements where each element corresponds to the cubes taken out of the bag. So we've got What this says is in this set we've taken out 3 blue cubes, 4 red cubes. In this set, this many and this many, and all those sets were the tries where the guy was taking out the cubes out of the bag in each game. So what we had to do is simply check if every single of these sets, if we didn't have the number that's greater than those. So we had to check that let me just quickly have a look which one was which. Red, green, blue. So we had to check that the blue chips in each set taken out were less than 14, because if for example in any of the sets, like in here 20 red, we've taken out 20, but the back we've had, oh my god, I'm so chaotic. The task said that the maximum number that can be in the back is 12 red, yeah, and we can see that in this set we've taken out 20 red, which means that it's impossible that this game was played with this bug. And that's what we had to say, check which games were possible to play within each bug. So what we did is we simply mapped through the sets of each game, extracted the blue, green, and red rollouts, and checked if those numbers are greater than those. If any of those numbers were greater, that means that the game was impossible to play, and we've been summing up only the games that were possible, so that were returning the true and not the false. I know it's quite chaotic, but I hope you understand what I mean. And yeah, we got a star. Now let's go through part 2. So let's read through. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question in each game you played. What is the fewest number of cubes of each color that could have been in the bag to make the game possible? Let me just read through again. What is the fewest number of cubes of each color that could have been in the bag to make the game possible? Okay, let's go through the example. Again, consider the example games from Mario. So we've got the same test input, and in game 1, the game could have been played with as few as 4 red, 2 green, and 6 blue. If any color had even one fewer cube, the game would have been impossible. Okay, so I understand. What we need to do is go through all those sets and get the highest out of the blue, the highest out of the red, and the highest out of the green, and that's gonna be our solution, which is the fewest cubes that would have had to be in the bag. Because if, for example, I went for 1 red, that would be impossible, because if the bag had 1 red, the game would have been impossible because we've rolled 4, and we're looking for the fewest possible cubes, which means that the bag had to have at least 4 red cubes, because otherwise this set would not be playable. And so if the 4 is the highest number, we know that that's at least the 4 is the fewest cubes that the bag should contain, because, well, the bag could contain as well 5, 6, 7, or the higher number. The games would still be possible, but the task is asking us for the fewest number of cubes, and the fewest number is gonna be the highest of each color in given sets, because we need to be yeah, I hope that's clear. So the power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. Oh, okay, so we've got a Power Ranger of a cube. Okay. The power of the minimum set of cubes in game 1 is 48. Minimum set of cubes in game 1 is 48 because that's is equal to number cubes multiplied together. Okay, so we've got 4 times 6 blue times 2 green, so it's 24 times 2, which is 48. So we're multiplying the results. Okay. Now I get it. Adding up these 5 powers produces, so what we need to do is multiply, so get those powers, which means multiply those numbers, those results for each color, and then for each game sum it up. Okay, I get it. It's not, it should be quite easy, but let's have a look. So let's get our solve part 2 function, and now we're gonna solve part 2. And so now we're gonna go through the same thing. Because we're summing up at the end anyway, so we're gonna just simply use the just function accumulator game and index if we need. Oh, sorry. Let's set the initial value to 0, and what we need to do is, well, we're definitely gonna need to map loop through the games. So for each game, what we're gonna do, for each game we're gonna loop through the sets. So because we need to check every single set, and so what we can do is simply go through those sets and split the get an okay. So we're gonna get an array. We're gonna get an array for which gonna have arrays for each color. So we're gonna get color array, which is gonna be equal to, which is gonna have 3 elements, and each element is gonna have array with elements corresponding to a certain color. So first element is gonna be for red, then for green, and then for blue. Okay. And then we're simply gonna go through every single set. So for example, I don't know, this is our set, and out of this set we're gonna push the number to a certain element of an array. So blue, which is, we've had 1 blue, so we're gonna push this 1 to the second element. We've had 2 greens, so we're gonna push the 2 to the blue is third, and we're gonna push this green to the second element. Yeah, and what I mean is we're gonna have an array containing some numbers of how many of certain colors were included in each set. So for example, we've had 4 sets and they've had those amounts of green. So out of this, what we're gonna have to take is the highest value, and that's gonna be our response. And we're gonna do this for all those 3 arrays. Then we're gonna multiply it together and sum it up, and that's gonna be our solution. It's quite easy. So what we're gonna do is we're gonna so let's start with first elements, which is red. So let's go. We're gonna push. So just to be clear, we're looping through the games. We're looping through the games. Yeah, for each game. Yeah, we're using the for each loop to go through each game, and for each game we're looping through the sets. So now for each set we're gonna push element to the wait, what? Yeah, sorry. This array needs to be declared here because we're doing that for each game, but we're looping through each set. Yeah, that's fine. So what we're gonna do is we're gonna push an element. We're gonna do the same thing that we've done in the first part. So we're gonna parse int and get the set.filter element, and we're gonna do first one is red. I don't know why, that's what I've chosen. And we're gonna do this for every single color. So second one is green. So we're doing the same thing that we've done in part one. We're just taking out, for each set, we're taking out a certain color that was rolled out. And we're just putting that to this array. So just to show you what we're getting out of this, let's temporarily quickly console.log color array. So let's run this, and you can see that this array is having you can see that this array is having that each game for each game we're getting this color array, and it has three arrays, each one corresponding to each color, and each one is having the rollouts for each color, which is what we wanted. And now all we need to do is get our solution done. So yeah, but wait, why do I do this? We've got the reduce function already, and for some reason I've done this. We don't need that because we're already looping through our games using the reduce function. Oh, I'm crazy. Sorry about that. Now we need to return. We need to return what? We need to return something. So let me just quickly think. So for each of these arrays, we need to take a maximum value. So automator plus, and now we're gonna let's just start with this. Let's just map through the array. So mapping through every single element in here. For each of the color array, we need a maximum number. So we're gonna use the max function. And since we've got array, we can use the destructuring of a because this is an array, so we can use this destructuring operator so we're gonna have these three elements, and we're gonna take out the maximum value. but we can see that we're getting the not a number as the nulls as well, in case there was no color in a certain set. So we need to map for these colors and get rid of those nulls. So if is none, there's element where we can go if it's a number. Okay, if it's not a number, yeah, we're simply gonna return 0, and if it's a number, we're gonna return element. That's fine. And this is our map. So for each color, we're taking the maximum values. So let's console log how our color array looks like now. Console log, what the hell? It's quite late, I'm already losing my mind, something's wrong. No, what's going on? So we didn't get rid of those nulls. Why not? Is not a number. Yeah, if it's none, we want to return 0, else we're returning an element. And why is it not working? Oh, wait. Oh, there we go. Yeah, okay, that's fine. So we can see that we've gone. Oh, God damn it! There we go. We can see that we got rid of those nulls, which is good. And we've got the maximum values. In each color array simply contains the maximum values for each color now, which is what we want. That's fine, because we've got maximum value. Yeah, okay. So what we need now is we simply need to return. We need to multiply it and sum it up with our reduce function. So what we need to do is return accumulator plus and we need to multiply color 0 times color R1 times color R2, and that's what we're multiplying and then summing up for each row, so that should be our response. And let's just console.log our response. Let's have a look. And the response is 2286, and we can see that the response is 2286. We've done it in 3 milliseconds, which is okay. Let's have a look. Oh, right, no, this is the test input, so now we need to switch back to our regular input and get the solution. Okay, my bad, pardonnez-moi. Mi scusi. Let's have a look. There we go. So our response is 83105. Let's have a look if we get a star. 83105. Do-do-do-do. Ba-doom-ts. There we go. We got a second star. There we go. So day 2 is solved. Again, it was quite way too long, but it takes me quite a long time because I'm new to narrating, to talking during during my coding, and trying to explain my thinking process and code at the same time makes the videos quite long and chaotic. But yeah, I hope I'll get better with it. So I hope you guys enjoyed. We've got the second day of Advent of Code 23 solved. And thanks for watching. Stay tuned for more videos. Subscribe for more content.